Today we are going to do class 10 triangles Pythagoras theorem. This theorem is really very important. In the lower classes, you must have learned about this Pythagoras theorem. Now in 10th, we are going to prove this theorem, Pythagoras theorem, using similarity concept. So let's start solving this Pythagoras theorem. What does Pythagoras theorem says? Pythagoras theorem says that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the other two sides square. So we used to say in short form that hypotenuse square equals to one side square plus other side square. So here we know this Pythagoras theorem, like it is invented by the great mathematician Pythagorean. So here we know that the hypotenuse square equal to one side square plus other side square. It is applicable for a right angle triangle, right? So let's first analyze for a theorem what is given to prove construction and so on. So let's see, here it is given that in a right angle triangle. So given that there is a right angle triangle, let's give a name. So let's draw the diagram first. So in this triangle ABC, we know angle B is 90 degrees. That is given. And we have to prove that hypotenuse square, that is AC square, is equal to the sum of the squares of the other two sides square. So here given, we will write given is in triangle ABC. So in triangle ABC, we know that angle B is 90 degree, or we can say a triangle right angled at B. So triangle ABC right angled at B, you can say, or in triangle ABC angle B is 90 degree, therefore it is right angle. We are supposed to prove square of the hypotenuse equal to the sum of the squares of the other two sides square, that is AC square equals to AB square plus BC square. As we have learned here, similarity of triangles, using that concept we are going to prove. So first we need to divide this triangle into two triangles. Then only we can prove that the two triangles, by using similarity, we can prove that the triangles are similar. So for that we take a construction from the vertex B. So we draw a perpendicular. So here we write the draw perpendicular BD. So we are drawing perpendicular BD to AC. So construction here is draw BD perpendicular to AC. We are drawing BD perpendicular to AC. So here the motto of taking the construction is so that we can divide this bigger triangle into smaller triangles and prove what we want. Now when we see the LHS and RHS, let's consider first RHS. So first we will find what is AB square. Next we will find what is BC square. After finding AB square and BC square, we are going to add it. Now to find AB square, we have to consider two triangles in which AB exists, the side AB exists. So if we consider two triangles, it is triangle ABC and triangle ABD. So if we prove triangle ABC, the bigger triangle in ABD, if I prove that this triangle, smaller triangle, the bigger triangle is similar, we can find what is AB square. That means by using the property, the two triangles are similar, corresponding sides are proportion. So when we see this triangle ABC and triangle ABD, we can find that angle A is common in both. We can find for triangle ABC and triangle ABD, angle A is common and we can find right angle. So by AA test of similarity, we can prove the triangle similarity very easily. So let's see the proof. So first we consider our aim is to find AB square. So for that reason, we are considering the bigger triangle ABC and the triangle ABD because it has the letter AB, the side AB. So here first we are considering the triangle ABC. So we are first taking the bigger triangle ABC and triangle ADB. So I am considering this both the triangles. Here I can say angle A and angle A, they are equal because they are common angle. They are common angle. And then we can find the bigger triangle angle B is equal to angle D, that is each is right angle. Here you can find their right angle. So angle B and angle D is equal, therefore each is right angle. Therefore we can find the triangle ABC similar to triangle ADB. Here we can say by AA test of similarity they are similar. So here you can find both the triangles are similar. Once the two triangles are similar, Our aim is to find AB square. So let's write their corresponding proportion. I want AB. So AB is actually, before we write the corresponding side, first check whether the correspondence is written correctly or not. Even if you don't write the correspondence here, it is okay. But while writing the similarity, you have to be very careful. So A is the first letter in the triangle ABC. A is the first letter in triangle ADB also. Angle B is 90 degree. Angle D is also 90 degrees. So correspondence is correct. So here we can write AB, that is first and second letter, upon AD equals to, we want AB first and third. So here the first and third is AC upon EB. So that is CSST. Corresponding sides of similar triangles we can say. Now when I cross multiply, here we will get, when we cross multiply, here we are getting the fifth one, AB square. See, AB into AB, AB square equals to AD into AC, or AC into AD. Now once we got AB square, now our aim is to find what is BC square. So to find BC, again we will consider two triangles where BC exists. So triangle ABC again, and the smaller triangle, that is BDC. So here we will consider triangle again. The next triangle, consider triangle ABC, and triangle, when you consider the triangle, you can say here BDC. So here we are considering triangle ABC and triangle BDC. So when we write this triangle similarity, here we can find that angle C is repeating. Can you see angle C and angle C are common angle here? So here we can say angle C equals to angle C, that is their common angle. And again 90 degree we can take. In the bigger triangle, angle B is 90 degree. In the smaller, D is 90 degree. So again we can say each is 90 degree. Therefore, can I say that both the triangles are similar? Yes. So here we can say, therefore triangle ABC similar to triangle BDC. So both the triangles are similar by AA test of similarity. Now first check, have we written this correspondence correctly? Let's check. A, here first we'll see C. C is common angle, C is common angle, correct. Angle B is 90 degree here. Angle D is 90 degree in the smaller triangle. So it is correct that angle triangle ABC similar to triangle BDC. Our aim is to find BC. BC is the second and the third letter. So here we'll take BC second and third letter, which is the second and third letter here, DC. Similarly, we are interested in BC, which is in the second case, second triangle, first and third letter, which is the first and third letter, AC. So it is AC upon BC. Again we write CSST, corresponding sides of similar triangles. Therefore, what you will have, BC square equals to, we cross multiply, we get DC into AC. Now can we find out RHS? We found what is IB square, we have found what is BC square. So let's add 5 and 10. So if I add, I get AB square plus BC square 5 and 10. So here the fifth one is RHS AC into AD plus BC into AC. So what is common here? AC is common. So AC if I take common, I will get inside the bracket AD, one sec here. So we are having AD. Okay, so here we have AD plus DC. Can you see that? So here AC we have taken common. So inside we will get AD plus DC. What is AD plus DC? AD plus DC is nothing but AC. So students, we have AC into AC, that is AC square. So we have proved beautifully the Pythagoras theorem using similarity concept. Here we should not by heart but understand that we need AB square, we need BC square. So for that we did the construction, students. So in triangle ABC, angle B is 90 degree. We had to prove this. We did construction and we divided the whole triangle into two triangles. So to find AB square, we took two triangles in where AB exists. So we proved the two triangles similar and therefore corresponding sides. Similarly, to find BC square, we took two triangles where BC, here it is there. BC is the side, and then after proving that, we said BC square equals to DC into AC. We added up and we got AC square. So I hope students you have understood this Pythagoras theorem. So the same thing we can say generalize and say that suppose if a perpendicular is drawn. So if I take the perpendicular for the same here we can say that here, one sec students. So here we can take that if I take the triangle ABC, and if I take a right angle triangle, here if the perpendicular is drawn, so from this we can infer that if the perpendicular is drawn from the vertex from the vertex to the hypotenuse, then all the three triangles are similar to each other. That is what we have done. That is to find AB square, we took the bigger triangle and this triangle. So here we can say that is triangle ABC, and triangle we have taken ADB. Again, for the smaller triangle, that means to find out BC square, we took triangle ABC, and we proved that it is similar to triangle. Now here C is common, right? So we proved that triangle BDC. So once we prove that this triangle ABC is similar to triangle ADB, ABC is also similar to triangle BDC. So from this we can infer all the three triangles are similar to each other. That is triangle ABC similar to triangle ADB, similar to triangle BDC. So from this we understand that in a right angle triangle, if from the vertex, if you draw a perpendicular to the hypotenuse, the triangles that is formed on either side are similar to each other and to the whole triangle. And this we can use this fact for proving in the application based of sum. So I hope students you have understood Pythagoras theorem very clearly and understood the concept rather than by hearting. You must have done it. Okay. Thank you students.